हो जाएगा. Assalamu alaikum dear students. Now today we read about the resistance in series and parallel circuits. In our previous lecture, as you know, you are studying the parallel and series combination in the capacitor case. Capacitor is known as the charge storing device in which the amount of charge is stored in the capacitors, and capacitor construct on a two thin metal plates separated by the insulating materials called dielectric medium. Now, in capacitor case, Coulomb's law is applicable, but in the resistors case, Ohm's law is applicable. You know that you know that resistance are connected in two combinations, series and parallel. First of all, we are talking about the resistance in the series circuit. When two or more resistors are connected end to end, they are said to be in series. The resistance could be simple resistance or bulb or heating elements or other. You know what is resistance? Resistance is the force which are opposition to the flow free of electrons. ठीक है? Provide the opposition in the front in the way of the flow free electrons. If you have three resistance R1, R2, R3 connected in the series, the amount of charge passing through resistance R1 must also pass through the resistance R2 and R3 since the charge cannot be accumulated anywhere in the circuit. When the amount of charge in the series circuit is amount of current is the series circuit is the same through each resistance as this is the circuit diagram of the resistance when are connected in the series combination. आपका इन्होंने इन्होंने एक स्क्वायर शेप में बट किया, बट इट्स योर ओन चॉइस कि आप इस रेजिस्टेंस को इसकी दूसरे एंड पे भी जोड़ सकते हो, फिर इसको तीसरे एंड पे भी जोड़ सकते हो और बैटरी यहाँ पे अटैच करके इनका कनेक्शन करोगे. व्हेन यू आर प्रोवाइडिंग द voltage through a battery or any other source, so then in other words you can say you provide the electric potential. ठीक, electromotive force will convert this battery source energy into the another form of energy, and after voltage drop you can create the potential difference between these two ends. ठीक है? This is the symbolic representation. This is the you can understand the resistance by this figure कि resistance को आप लोग इस figure से हम लोग represent करते हैं. ठीक है? In actual figure we know that when you have two or more resistance, so then you can uh, calculate the equivalent resistance. Here equivalent resistance is denoted by the S, but you can also denote it by the E. The amount of current is the same in the whole circuit among the each resistance. This is the actual figure of resistors. Here is some color bending on the resistance, but in this of course this is not important. You can just understand इन कलर बेंडिंग की भी कोड होते हैं जिनके ऊपर वर्किंग होती है, बट इस पर ब्लू ग्रीन रेड ऑरेंज बैंड लगा होता है. दिस इज द एक्चुअल रियल फिगर ऑफ रेजिस्टर्स. Here you notice that there are three resistors of different amounts have been attached in the circuits in the series form. This is the battery provide the electromotive force and the voltage drop among the two batteries. This is the actual photo. Due to this reason, the current I, when the potential difference, then the potential difference is created among the terminal. So then amount of current is producing in the circuit, and the current I among the whole circuit along the circuit through all these systems is the same. You know that capacitor case में हम कूलम्स लॉ को फॉलो करते हैं, बट रेजिस्टेंस केस में हमारे पास ओहम्स लॉ है कि ओहम सेज कि वोल्टेज इज डायरेक्टली प्रोपोर्शनल टू द अमाउंट ऑफ द करंट प्रोड्यूसिंग इन द सर्किट. when you know remove the proportionality sign and introducing the constant r, this is known as the resistance. Current I through all resistors is the same according to the ohm's law. If some current pass through different resistors of different values, the potential difference across must be different. क्योंकि if same current pass through the different resistance, potential difference because note that figure amount of resistance is not same. This is 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. It means each resistance provide different amount of resistance to the free electrons. अच्छा देखिए 2 मिनट free electrons. हाँ, ठीक है. Free electrons. Due to this reason, because the amount of resistance, each resistance is different, so it provides different amount of resistance in the way of the free flow of free electrons. So that right amount of current is same, but the voltage drop in each terminal. When the current passes through this resistance to and reaches at this point, so then when it passes through this point, the resistance will here is some voltage drop at this point. Then it reach to the other resistance. Then again the voltage drop at this point. So similarly, the voltage among the three each across the each resistance for potential difference is created, and voltage must be different. Let V1, V2, and V3 be the potential difference across each resistance. So by applying the Ohm's law, we can say that voltage 1 is equal to the amount of current is same and R1 is different. V2 I is equal to IR2 and V3 is IR3, but the total voltage is equal to the sum of the voltages across the each resistor. Like this, you can add the different amount of voltage. As you know, we can teach in our the previous lectures when we are talking about the capacitors in the series and parallel combination. So when the amount of voltage is different, your charge, producing charge is different. So you can write the all the charges and the voltage in the sum of form and given that the certain name. IR1, IR2, I3, I is the common. So we take it as a common multiple, and the remaining is became IRE. Here is the R equivalent resistance is represented by the RS, but you can also represent it by the RE. When several resistors are connected in series, the total and equivalent resistance is the sum of the. When several resistors are connected in the series, when you are connected the resistance more than one value, so then the total equivalent is sum of the equivalent. So total आपके पास जो total equivalent resistance होगी वो greater than होगी individual values से. This is example number 2.8. You can do also your example from your book 14.4. Calculate the equivalent resistance for the circuit which is connected to the 12-volt battery and also find the potential difference. ठीक है. These are two amounts of resistance, 4 ohm and the 6 ohm. In the you must know that before solving the question, you must read the statement of the given question clearly. कि which combination is uh, जो यहाँ पे कौन सा जो combination है वो यूज है तो सीरीज यूज हुआ हुआ है. You can also buy your figure. This is the series combination. Solution. Equivalent resistance का formula आपको पता है R is equal to R1 plus R2, so then it is equivalent to 10 ohm. The current in the circuit is V is equal to equivalent होगा voltage battery जो है वो 12 24 वोल्ट की दी हुई है. Equivalent resistance are calculated above step, so then it is equivalent to 2.4 amount of current. Voltage across each resistor. So this formula V is equal to IR1. So then V1 जो होगा वो आपके पास I current amount is same in series circuit. So then 2.4 ampere is used, and the ohm resistance value is different. So multiply by 4 ohm, it is equal to 9.6 volt. Similarly, we can calculate the second voltage across the next terminal. Resistors in parallel. Resistors are in parallel when they are connected across the same potential difference. In this case, the total current that leaves the battery is separated into the three separate parts. Okay, when you are talking about the when you are connecting the resistance in the parallel combination, so you must know that because here is the current has more than one path to flow. As in the capacitor case, I told you when current has one path, current has more than one path to flow, so then it will always select the lower potential path, the path which has more less potential, so it will move on that point. So that's the reason the amount of current is not same in this amount of current is not same in the parallel combination. As in the capacitor case, the amount of charge is not same in the parallel combination because current has more than one path, the charges has more than one path to flow. Resistance R1, R2 respectively. This respectively means that I1 is stands for R1, I2 is R2, and I3 R3. When the term respectively used, then you must know the thing. The first value is for first one value. Due to the conversion of charge, total current in the circuit is equal to the sum of the current through each of the capacitor because the amount of current is not same in the circuit. So that's why you can calculate the all values of current passing through the passing through after the each resistance you are calculated, and then give a equal name I and represented by the capital I. This is the circuit diagram of resistance when they are connected in the parallel combination. You see clearly seen that these resistors are not connected each other. In series, the resistors are connected एंड टू एंड टुगेदर, बिकॉज इट मीन्स कि वो आपस में भी एक दूसरे के साथ कनेक्टेड थी, बट in this case parallel combination the resistors are not connected individually each other. They are directly connected to the battery terminals. Each resistance had directly connection to the battery terminal. So when you are apply the voltage through some battery or a cell or any other source, it otherwise you can apply a electric potential and electromotive force, which convert the battery energy into the appliance energy. You are connected in the circuit. An amount of current is producing and flow in the circuit from higher potential to the lower potential. And here is the amount of current, because here is the when current is flow, current has more than one path to flow. So which terminal has possessed the more less potential, the current flow this way. And equivalent represented here is the equivalent represented by the P. You can also represent the equivalent resistance by E. This is the actual figure. दिस इज द ये एक्चुअल फिगर आपकी रेजिस्टेंस की है, ये इसकी दो मेटल की वायर्स होती हैं, ठीक है। इसका कोई और कीप इट इन मस्ट कीपिंग योर माइंड रेजिस्टेंस हैज नो नेगेटिव एंड पॉजिटिव टर्मिनल, 1 ohm, 2 ohm and 3 ohm. When the current producing by this battery, so then they are moving from higher to lower potential, so they always use just select the less lower terminal path, because the 3 kilo ohm has more resistance as compared to the 2 kilo ohm and 1 kilo ohm, ठीक है। तो 1 किलो ओम में कम रेजिस्टेंस होगी तो जो करंट होगा वो आपके पास ऑटोमेटिकली इस पाथ से ज्यादा गुजरेगा, बिकॉज दिस रेजिस्टेंस हैज लेस रेजिस्टेंस वैल्यू, सो करंट इज गोइंग बाय दिस वे। Amount of current is different. Each resistor, since the voltage across each resistance is same, but amount of voltage is same. The reason behind is that because each resistance is directly connected to the battery, and battery provide the equal amount of voltage to each resistor. So then you can know the Ohm's law formula V is equal to IR. When you are finding the value of I, you can separable by amount of current, unknown variable on the one side of the equation and second is on the other. The equation will become this. If we take the voltage as a common, because voltage is same in parallel combination as in the capacitor case also, so then it will become the I is equal to V of R P R E. Here Rp is the equivalent resistance of the parallel combination of the resistance. Then when a number of resistors are connected in a parallel, the sum of the reciprocal of the values of the resistance is equal to the reciprocal of the effective resistance of the combination. You know this formula. When you are, as you read in the capacitor's case, तो पैरेलल सीरीज कॉम्बिनेशन में इक्विवेलेंट रेजिस्टेंस जो थी वो आपकी इंडिविजुअल रेजिस्टेंस से क्या थी, लेस थी, ठीक है। पैरेलल कॉम्बिनेशन में आपकी जो इक्विवेलेंट रेजिस्टेंस थी वो आपकी each resistance से individual resistance से ज़्यादा था, okay। Now this is the example. The value of equivalent resistance is parallel combination. The value of equivalent resistance in parallel connection will be lesser than the each individual. ठीक, parallel combination में the amount of equivalent resistance is lesser than the individual. But capacitor case में the amount of equivalent resistance is greater than the individual capacitor. Household appliances are always connected in the parallel combination. If someone asks by yourself, if someone is asking to yourself, why we are using the parallel combination in our household wiring, so you can say that because if one appliance is not in working condition, then it's not affected to the working of other appliances. ठीक है, कि अगर पैरेलल कम्बिनेशन में होगा तो अगर आपकी एक अप्लायंस खराब होती है तो अगर आपकी सीरीज का तो ड्रॉबैक क्या है कि अगर आपकी एक खराब हो जाती है क्या होगा, तो वो आपकी अब अगर ये वाली एम्प्लॉइज काम नहीं कर रही तो दूसरी भी काम नहीं करेगी, रुक जाएगी। बट पैरेलल में आपको ये एडवांटेज होता है, अगर एक काम नहीं कर रही है तो जो दूसरी लगी हुई है पैरेलल, तो सारी उसकी वर्किंग में कोई फर्क नहीं आएगा, ठीक है। जिस वजह से पैरेलल जो होती है वो यूज होती है हमारी हाउस होल्ड में। This is the another example of 2.9 in which the amount of finding the same things as in the example number 2.8, but some little bit different because there is a combination of parallel, so we can change the formula. Equivalent resistance is calculated by this formula, so simply substitute all the previous values in this question. You can resistance I is equal to VR1 24 volt divided by 6 ohm, ठीक है। Amount of current is different in the each resistance, so I is equal to I1, I2 is given, so 6 ampere and 4 ampere is multiplied, then is equal to 10 ampere. Clear? I hope you will clear this topic. If you have any queries, then you will ask